So in this question, we have been given the relationship between the average velocity of a body and time. So guys, pay attention. We have been given the average velocity and the time. Okay. Now keep in mind that if you know the average velocity and you multiply it with time, then you end up getting the displacement or the distance, which is same in this case because the question tells us that the body did not change the direction of motion. So it basically means that the displacement is same as the distance. Okay, so average velocity and time, this graph is given to us, and we want to know the graph between the instantaneous velocity and the time. So guys, let's try to understand how do we write the instantaneous velocity. So V instantaneous will be given as ds by dt. All right, and how can we calculate the displacement? We can say it is the product of average velocity and the duration for which the motion has taken place. So this graph is telling us that if the motion took place for 1 second, then the average velocity for that 1 second would be 2 meter per second. If the motion took place for 2 seconds, then the average velocity for that 2 seconds, the 0 to 2 second period, would be 2 meter per second. If the motion took place for 4 seconds, then the average velocity is 3 meter per second. So whatever value you choose, for example, you have chosen a point on this graph, so that point will have a certain value of time, that will have a certain value of average velocity. So if you multiply these two, then you will get the displacement up to that second. Okay, so what we are getting here is displacement. This is displacement up to that second, up to t seconds. So if I differentiate it with respect to time, I will end up with the instantaneous velocity. So this will become VAB into 1, that is derivative of t, plus t times dVA by dt, that is slope of the given graph. So understand this, guys. From the given information, we can write down the instantaneous velocity by using V average plus t times the slope of this graph. Now, what we have to understand here is uh, how we the function V average as a function of time. So if you notice from 0 to 1 seconds, it is a straight line passing through a region with a slope of 2. So it should be 2 times of t as t changes from 0 to 1. Okay, then it remains constant at 2 for t ranging from 1 to 2. Okay, then it again becomes a straight line of slope 1 by 2. So slope is half into t plus if I select t as 2, I should end up with a value of 2. So that means I should put 1 here because if I select t as 2, it will become 2 by 2, 1, 1 plus 1 is 2. So this should be the function. Like this is the function of V average versus time. From the given graph, we have written this down now. Substitute it here. Okay, so 2t, V average is 2t and t times the slope. Now, if this is the function, the slope will be 2. Okay, so this is applicable for 0 to 1 seconds. Okay, 0 to 1 seconds. Now, for 1 to 2 seconds, 1 to 2 seconds, V average will be 2 and t times the slope. Slope is 0. Okay, the slope is 0. And then from 2 to 4, what we will do? We will write t by 2 plus 1. So t by 2 plus 1, that's V average plus t times the slope. The slope is half. Okay, so overall, the function that we are getting, let me write it here. The function that we are getting for V instantaneous. Okay, that function is 4t for t ranging from 0 to 1. Okay, then it is constant value 2 for t ranging from 1 to 2. Then this is t plus 1 for t ranging from 2 to 4. Now, we can make the graph by using this. So, if we try to make the graph, the kind of graph that we will get will be somewhat like this. Okay, I'm trying to draw it. So, it will appear somewhat like this. So for the first 1 second, it's a straight line passing through a region with a positive slope, and it will rise till 4. So if this is 1, then this is 4. Okay, then for the next 1 second, it has a constant value of 2. There is half of the side. So for the next 1 second, it has a constant value of 2. Okay, then for the next 2 seconds, it follows t plus 1. Okay, so when t is equals to 2, this will become equal to 3. Okay, so there is a sudden jump from 2 to 3, so that is mid value of this. So somewhere around here you can say. Okay, so this is 3 and this is 2. So it starts from here and then with a positive slope, it goes till 5. All right, as the time goes from 2 to 4, Okay, it goes till 5. So the point that we are looking at is like this. Okay. So overall graph that we have got would appear like this. A straight line, then a sudden drop like this. Okay, then a constant value, then a sudden rise, and then increasing value like this. So this is the kind of graph that we should be expecting, and this is indeed the answer as we can see. So this is the answer. So I hope you understood the solution, everyone. Take care. All right, let's have a look at this question. So a passenger standing at a platform at the beginning of the nth coach of a train. If the train starts moving with a constant acceleration, the third coach, which is the nth coach, passes by the passenger in delta T1, and the rest of the train, including the third coach, that is the nth coach, passes in delta T2. How many coaches are there? All right, guys. So in this question, first of all, there is an assumption, and the assumption is that the gap between two train coaches is negligible. So keep in mind that we are solving under this assumption that the gap between two train coaches is negligible and all the train coaches are of identical length, which is a quite a reasonable assumption, I would say. Okay, so to understand what is going on, let's consider a train with six coaches. Of course, we are not saying that six is the answer, but it will help us to think. So according to the question, third coach. So this is the nth coach, and let's say this is capital Nth coach, where capital N is the total number of coaches in the train. Okay. Now, if the length of one coach is L, according to this information, the train was starting from rest, and then in delta T1 time, it covered the one coach length. All right. So we will write L is equals to half into A, where A is the acceleration, into delta T1 square. So that would be my first equation. Okay, now according to the information given here, delta 2 is the time in which all these coaches, all right, they all cross. So how do we get this number? So consider the example for a train with six coaches. These are four coaches. How do we get the number four? So that is six minus three plus one. All right. So I would say that n minus a small n plus one, this is the number of coaches that gets crossed in delta T2 time. So this number into N should be equal to half A delta T2 square. So that would be my second equation. So we have to find out the value of capital N. Small n is given to us as 3. So let's take the ratio of these two equations. So if I do delta T2 square divided by delta T1 square, we will get this half A will get cancelled, L will get cancelled, and we will get N minus N plus 1. In other words, the value of capital N can be written as delta T2 by delta T1 a whole square plus N minus 1. And if we substitute the numbers now, delta T2 is 20, delta T1 is 5. So 20 by 5 is square plus 3 minus 1. So this is 4 square, 16 plus 3 minus 1, which is 18, which is the correct answer. So this is the total number of coaches. Apart from this, the question also asks in what time interval did the last coach pass by the passenger? All right. So the time taken for all these coaches. What's the count of these coaches? The count is n minus n plus 1. All right. So for all of them to pass, we know that the time taken was delta t2. So for all of these to pass, like last but one, all right, starting from small n till last plus one. So whatever this count was, we are subtracting one from that, and we are assuming that to cross this length, the time required was delta 3. So I will now write n minus n plus 1. So this is the same number that I have written here. And now I'm thinking about one less coach. So I will minus 1. So this length was crossed in a time delta T3. So delta T3 square is this. Now we have to get the value of delta T3. So delta T3 will represent the time in which this entire length was crossed. Delta T2 is the time in which this entire length was crossed. The difference of delta T3 and delta T2 will give us the answer. So what do we do now? Let's name it as equation number third. So equation number two, which is this one, equation number two minus equation number three divided by equation number one will actually help us to get rid of half A and L. So equation number two minus one. So what I'm planning to do is that uh, half A T2 square minus half A T3 square. I'm managing the right hand side of these equations. divided by half a T1 square should be equal to now the left hand side of the second equation, this one. Okay, so that would be n minus n plus 1 into L minus the right left hand side of the third equation would be this gets cancelled. So it would be n minus n into L divided by the left hand side of the first equation is simply L. Okay, so what do we end up with? This half a gets cancelled. Okay, this L gets cancelled. So we end up writing delta T2 square minus delta T3 square is equals to delta T1 square. And here this n gets cancelled, this small n gets cancelled. We are only left with 1. So from here we can conclude that delta T3 square is equals to delta T2 square minus delta T1 square, which basically means that delta T3 is equals to root of delta T2 square minus delta T1 square, and therefore the answer would be the difference of delta T2 and delta T3, which means it is delta T2 minus minus square root of delta T2 square minus delta T1 square. So this will become delta T2 was 20 minus root of 400 minus 25. So this is 20 minus root 375. Now, how much will this be? So root of 375 plus 20 gives us somewhere around 39.36 seconds. So this is what we are getting. I hope I'm not committed any mistake. Okay, let's check the answer. Actually, my bad. Here, minus sign was there. I added this to. It should be 20 minus root of 375. How much was root of 375? That was 19.36. Okay, so the answer would be 0.64 seconds, as we can see. So we obtained this expression correctly. Okay, I just messed up a little bit here in the final calculation. Okay, so these are the answers. We obtained both of them. All right, students.